So hello everyone, and I hope everyone is having a good Sunday. I've had my coffee. I'm running a little late. I don't know. I was up at 5 a.m. but I get sidetracked. All right. Anyway, I want to talk about internal rate of return. All right. So internal rate of return is a function that's in Microsoft Excel, and you can see right here when I click on that little f of x. You see how it comes up right here. And if you can't find it, you could just type it right in here, and it'll hit go, and it'll search for it. All right, now, internal rate of return, by definition, is the point where the net present value is equal to 0, okay? It's the point where net present value equals 0. Now, you cannot calculate net present value easily. There's not a simple equation to calculate it, except, of course, if it's a perpetuity, okay? And then it's just 1 over 1 plus r, which is the internal rate of return, and that's easy to solve. You can solve for r in that case. But when it's multiple cash flows over years, you know, you're getting the present value of each cash flow, the squared, cubed, you can't solve for it. So the only recourse is to have Microsoft Excel do the recursion relation and find it, okay? So the question is, how do you do that? And the easiest way is just take all your cash flows, just put them in Excel, okay? And then you could copy them into here, and I'll show you how to do that. And then you take a guess. Now, if you leave guess blank and just leave it as, blank or 0, it'll do its own guess, and most of the time you'll be close. But internal rate of return is a very complex function, and there could be multiple internal rates of return, so it'll drive you crazy. But let me just show you how to do this real simply. Again, don't try to calculate this with an equation, all right? So let me just say, okay, so I'm going to go over here, all right? All right, minus, so you invest $500. I'll make that minus, all right? And I'll put 100 here, and 50 there, and 75 there. And another 100 here, and another 150 there. All right, so I think you get the idea. I can go on with this all day. So here's the money I invested, right? Minus, I made that minus, and here's all the positive cash flows that came in. All right, so I'm going to go over to here, and I'm just going to type IRR so you know what I'm talking about. So there's the internal rate of return. So I'm going to go over to here, and I'm going to make click f of x, and I bring up IRR. So see how simple that is? And all I do, watch, is drag. Come on, keep going, keep going. Drag it down. And I didn't place a guess, okay? But just to show you how you can make a guess, I'll say 0.05. All right, 5%. Let's say that's my internal rate of return. So I say okay, and you can clearly see now that my internal rate of return is minus 2%. I'm losing money on this investment, okay? So minus 2% is the point where the net present value is equal to 0, okay? So if so basically I'm losing money on this, right? So, but that's all you have to do. That's all you have to do. Now let me go over here. I'll change some numbers, all right? Make that 1,000. Make this 100. Now you see my net present value, how it's huge, right? And this is the point where the net present value is equal to 0, okay? 116%. Okay, so this is my internal rate of return. So what you got to do is change these numbers, and that's it. And that's all you have to do. It's just a string of numbers here. Okay, now remember the rule. If the internal rate of return is greater than your cost of capital, then basically, you want to do this project, all right? So you want this to be greater than the cost of capital. With the net present value, you want the net present value to be greater than 0, okay? So remember. All right, I'm going to bring up other stuff in a second. I'm going to pause this, and I'm going to bring up other stuff. Okay, so I brought up this article here from Investopedia. By the way, Investopedia is a really great site. I mean, you should have tons of good information. All right, so this one is called What is Internal Rate of Return? And the internal rate of return is a metric used in capital budgeting to estimate the profitability of potential investments. And you should read this. It's great. The internal rate of return is a discount rate that, and here it is, that makes the net present value of all your cash flows from a particular project equal to 0. IRR calculations rely on the same formula as NPV does. So here's the equation. So here's net present value, but when I set this equal to 0, then I can calculate IRR. But you can clearly see it would be impossible to do this by hand, okay? So to calculate IRR, using the formula, one would set NPV equal to 0 and solve for the internal rate of return. And you see what they say. It cannot be calculated analytically and must instead be calculated either through a trial and error or using software programs like Microsoft Excel. All right. So here they show you how to do it using Microsoft Excel. And I don't know if this is going to work. All right, but anyway, here's a little video, 4 minutes and 20 seconds. And they talk about the different ways of calculating it, all right? So let me see if this works. I hope this works. We'll see. Come on.
Internal rate of return is a core component of capital budgeting and corporate finance. Businesses use it to determine which discount rate will make the present value of the after-tax cash flows equal to 0. And any project that returns an IRR of greater than 0 adds some value. Now, the IRR is subordinate in the decision-making process to the net present value, and this is because we prefer an absolute dollar amount that's higher compared to an IRR that's higher. But let's go into how we can calculate the IRR in Excel. So the first thing we have is an initial outlay, which is the cost to build the factory or whatever, and then an estimated set of after-tax future cash flows. Now there's an issue with garbage in, garbage out. If our estimates are wrong, that's going to affect all of our calculations, but we are focusing on financial modeling best practices, which means that all of our line items are separate and distinguished, which means that if we need to change an assumption down the line, we can do so easily. What we're going to do is we have to discount each cash flow by the weighted average cost of capital raised to the period. So if we hit F2, you can see that we are discounting the first cash flow by the WACC raised to period 1. We're discounting the second cash flow by the WACC raised to period 2, so on and so forth. Now when we sum these present values and offset it by the initial outlay, we get the net present value of 472. Okay, that's all well and good. What does this 472 represent on a return basis? Here's where we use the IRR. Excel has two convenient formulas for this. The first one is the built-in IRR, in which case we will type in equals IRR. It asks us as a prompt for values and then a guess. We do not need to include a guess. I honestly don't know why Excel even has that, but if you were inclined to guess, you could. And you can see that we get an IRR of 57. Now, what does this actually mean in practice? This means that if our weighted average cost of capital actually was 57, then that would make the NPV equal to 0. And you can see how our model updates that automatically. And that's the nice thing about parting this model out line item by line item, is that we can play around with our assumptions and see what thresholds of WACC are required to have a profitable project. Now, 57% is so high of a return that we're never going to see a cost of capital that high, but if we made up lower numbers, now we can see that the IRR for this project is actually negative, which means that it is a value-destroying project. We don't earn enough on our after-tax cash flows to recover the initial outlay at this cost of capital. And further, because it's negative, we're never going to have a negative cost of capital, so this would be a project that we would avoid. Now, one thing about this assumption, and this is a weak spot of IRR, is that it assumes that each subsequent period is reinvested at this rate. So if we jump back to when it was 57, that is an aggressive assumption. What is more conservative is to say that the subsequent returns can be invested in the risk-free rate, which is like a treasury. And for that, we're going to use the modified IRR, which is still a very attractive 33% for this project. So we would use equals MIRR. It says give us the values, so we select the values including the initial outlay. Then it says give us the financing rate, which is our WACC, and we'll lock this in place. We'll hit F4 to lock this, and then it says give us the reinvestment rate, which is our risk-free rate. We'll lock this, and now we can see that we get 33%. And that is how you build out and calculate the IRR in Excel.